When you are trying to determine if a reaction is Sn1 or Sn2, as we've talked about, the first factor you should consider is the structure of the substrate. If that doesn't help you make the decision, you want to consider if the solvent is polar protic or polar aprotic. If that doesn't help you, if the solvent's not provided, you should look at the nucleophile, because that usually is going to be able to settle any sort of confusion that you might have about Sn1 or Sn2. In a worst case scenario, you may need to consider a fourth factor, and that is looking at the leaving group. And this is actually not a great factor to consider. It's not super helpful in predicting which mechanism predominates. The Sn1 reaction requires us to have an excellent, a very good leaving group, because the whole reaction starts by the leaving group falling off the molecule. So the reaction is dependent on the leaving group being good and easily falling off the molecule. Very good leaving groups, some examples are halogens, iodide, bromide, and chloride. Those are the ones that we definitely see the most often. The water molecule, which we learned comes from or can come from the hydroxide, the OH group being converted to a water molecule. The NH3, which also, like water, that comes from the NH2 group being converted into an NH3 group. So we've looked at examples of that, both of those cases. Similar to this, although we haven't seen an example of this yet, an alcohol. So that would come from converting an OR group into an alcohol, and that is exactly the same as this pathway over here. And then also another really good leaving group that I haven't shown you any examples of yet is OTS. That TS stands for tosylate. That's also a very, very stable leaving group. So the only real thing we can say about the leaving group is that the Sn1 reaction requires us to have a very good leaving group. And we can't really say much about Sn2 other than we can say neither reaction works with a bad leaving group. At some point in the reaction, whether it's Sn1 or Sn2, we are going to need to have a good leaving group. The bad leaving groups that we've talked about, OH, NH2, and then also, even though we haven't seen an example yet, an OR group. Those are all very bad leaving groups, but we know how to turn them into good leaving groups, so they aren't really a hindrance in preventing a reaction from taking place. Just requires us to perform an additional step. So all that we can really say here is that the Sn1 reaction requires a very good leaving group. The Sn2 reaction will work with an okay or good leaving group, or a bad leaving group that has been turned good. And this is why analyzing the leaving group is really the least useful and least reliable factor in determining whether a reaction is going to proceed by Sn1 or Sn2.